Hello everyone, welcome to our channel. So today we are going to continue the operating system module 1 part 2. Okay, so that is module 1 continuation. So today it's part 2. Okay, so fourth topic. Okay, so what is the fourth topic? So in the previous session we learned three topics. I'll pin the link in the comment section. If you have not saw it, you can go back and check it. Okay, learn the three topics and come back to the part 2. Okay, so we quickly move into the new topic. So that is fourth one. So next topic is computer system architecture. Okay, so computer system architecture means for designing the operating system we want to know the basic ideas about the computer architecture. Okay, so we roughly categorize the computer architecture into different types. So first one is single processor system. Okay, so the name itself says very clearly it's a single processor system. So what the single processor system says means it is a single process. Okay, the single processor. Okay, so it's the single processor going to handle all the CPU concept. Okay, it will be the one main CPU. Okay, the single processor will act as the one main CPU and it's going to handle all the task into the computer, means all the executor, it's going to execute all the instructions, okay, from the users. Okay, so that is called a single processor system. Okay, yeah. So again, so second one. Okay, so second one is multi-processor system. Okay, so in multiprocessor system, what happens? It is more than two or more processor. Okay, so join together and work for an efficient way. Okay, we'll join two or more processor, that is more than one processor. Okay, and they communicate each other. Even though they are separate, they communicate each other to share the data. Okay, they'll have a common bus, clock cycle, memory, everything they'll have a common. Okay, and they'll share the information by using all this one. Okay, and in the multiprocessor we have a advantages. Okay, so we have a three advantages. Okay, three main advantages of a multiprocessor. Whenever we use a multiprocessor, what are the three main advantages? First one is increased throughput. Okay, so it will increase our throughput. Okay, whenever it's a multiprocessor system. Okay, so multiprocessor will execute different programs. Okay, it can be simultaneously at the same time it can execute multi process, so that's why it increase the overall output. So that is nothing but increase the throughput. Okay, then economy to scale. Okay, economy to scale means it is less cost. Okay, the cost of implementing is not more. Okay, compared to the single processor system. Okay, so then increased reliability. Okay, it will increase the reliability. Okay, reliability. So what it does means whenever one part of the one processor is failing, the another process will continue to work, so that it will increase the reliability. Means the complete system will not shut down or stop working completely because it has more than one processor. If one processor is not working, another processor will work. Okay, so again, in this increased reliability, we can say there are two techniques how it has increased the overall working condition. Okay, so that is, so this is just a note. Whenever you're writing the answer, just for elaborating, you can include these two things also. Whenever it is increased reliability, it can be achieved with the two technique. Okay, one is graceful. Okay, one is graceful degradation. Another one is fault tolerance. Okay, so what is graceful degradation means whenever we have a multiprocessor, when one processor fails, the other process will take up its works and it will continue to work. Okay, only the overall output will slow down. Okay, second one is fault tolerance. Okay, in this fault tolerance, whenever one processor fails, the other process will continue to operate. The complete system will not stop. That is fault tolerant. Okay, these are the two ways. Because of these two techniques only, we are going to increase our overall reliability. Okay, so this is the multiprocessor. Okay, then they may ask you a sub question again. They may ask you different types of multiprocessor. Okay, so this comes under the multiprocessor topic itself. We can say different processor of multiprocessor system. Okay, here again we have two types. First one is asymmetric multiprocessor system. Second one is symmetric multiprocessor system. There are two type of processor system, multiprocessor system, that is asymmetric and symmetric. Okay, so in asymmetric, what happened, the first one in the asymmetric, what happened, so we can call this one as a master slave architecture. Okay, so what is master slave architecture means? See, the name itself says it's a master. They'll have a master and they'll have a slaves. Okay, so here what happened, each processor is assigned to a specific task by the master processor. Okay, and the master processor control all the other processor which are called as slave processor. Okay, and you can say the master going to allocate work and schedule the work, when to do, what to do. Allocate will tell what to do, schedule will tell when to do. So it's going to allocate and schedule the works to slave. Master will allocate and schedule the works to slave processor. Okay, so that is first type, that is asymmetric. Okay, so now we'll see the second type, that is symmetric multiprocessor. Okay, so in the short form we call it as a SMP, symmetric multiprocessor system. Okay, so here what happen, all the processors are considered as a peers. Okay, so there is no any master or slave, so everybody works together in a team, so that is called as peers. Okay, so all the in the SMP all will have their own register CPU. Only they'll have a common memory to be shared, to share the details. Common shared memory they'll have, and they'll have their own separate CPU. They'll have their own registers. Okay, so this is the different type of multiprocessor. Now again we'll go into the third type. Okay, first we saw single processor multiprocessor. Now we'll see the third type, that is clustered system. Okay, so don't get confused. This is a subtopic of a second part. Now we are again continuing the main topic. So that is next is clustered system. Okay, for reconfirmation, once again I'll repeat. So in the computer system architecture, we saw single processor, just we explained it. Then we had a multiprocessor and we explained it. Again in that we had a subtopic, that is different type of multiprocessor. Then now again we are continuing the main topic, third topic, that is cluster system, third type of system architect. Okay, yeah. So now what is cluster system? Okay, so here cluster system, what happened, we have a one or more systems. Okay, we can say two or more systems connected together. Okay, they're connected together. Okay, they'll have separate, they're both are individual separate system, but they're connected together. Okay, it can be through network. Okay, or any resource. Through any sharing resource we'll connect them. Okay, we connect more than one computer, that is two or more computers together. Okay, so that they can share the details. Okay, so they can share the details between them. If one or more system, okay, if one part of the system also fails in the cluster system, the service will continue. Okay, and what is the advantage of this one is the high availability. Whenever we say cluster system will join and work as a team, so there will be high availability in the general. Okay, we'll have a higher availability. Okay, again here also, in this also we have two type of clustering. Okay, that is asymmetric clustering. Okay, again symmetric clustering. Okay, so what this asymmetric clustering, okay, it's, we can say like odd standby mode. Okay, we call it as a odd standby mode. Okay, so one system in this will act as a odd standby mode, will other will while the others are running the application. Okay, so this or standby mode machine does not do any work. Instead of that, it will monitor as an active server. And the asymmetric, what happen, instead of doing the normal work, it will monitor the odd standby mode. One system will act as a monitor. Okay, it's going to act as a monitor and controls it. Okay, understood. If one system fails, so other will act as a odd standby mode automatically and controls the task. Okay, so then comes symmetric. Okay, here what happens, the two or more systems running application are monitoring each other, so there is no anyone actively act as a server or a leader, so everybody will monitor each other. So, okay, they'll monitor each other, means they'll control and send the information to each other monetarily, and this is more effective. Okay, and it is more effective and efficient. Why? Because there is no any separate person to monitor, everyone will be do their work, meanwhile they'll monitor the each other according to the requirement. So this is more efficient. Okay, so thank you for watching. We'll see the next part in the next class. Please do subscribe and like and share for more such videos.